everyone. Morning. How are you feeling? Great. Are you energized? Are you full of energy? Oh, that's just repeating myself. Are you full of energy to get started with a day full of learning? Yes? Yes, we are. And we're going to get started with a very long talk, a through rough overview of testing in Django and within Django. I'd like to say thank you to the organizers and the volunteers who make DjangoCon US happen. Because you and I, we have no idea how much effort it takes to bring a conference to life. And not only that, but also create a welcoming environment where we all feel safe. So let's just give them a round of applause. You might be wondering, who am I? I'm Anna. Hello. Hey, Anna. And this is my Twitter handle if you want to get in touch with me. There's nothing you probably haven't heard about me because there's nothing outstanding that I did in my life. Generally, I'm the kind of person who goes to work every day and tries to be the best developer I can become. I usually say I'm in a long-term, successful, and happy relationship with Python. I've been doing Django for the past couple of years. And in terms of community involvement, I usually do little things. Currently, I'm co-organizing the London PyLadies meetup. And I helped organize DjangoCon Europe last year. I sometimes mentor people, and most often I give talks at conferences. I recently joined a company called Street Team as a senior software engineer. So yes, questions. I won't be taking questions on stage, and there are two reasons for that. First is we actually might run out of time. And the second one is it never works out for me. I'll be honest, while I'm on stage, I'm a bit nervous, and by the end of the talk, it's getting a little bit tricky to think straight and give a proper answer to a question, and I feel like I'm actually doing a disservice. So let's take it off stage. I'll be at DjangoCon for the rest of the conference until Friday, so come and come to me if you have questions, comments, or feedback. I'll be happy to have a chat with you. Right, so now that we got to know each other a little bit better, let's get started with testing. We're going to take a trip all the way from version 1.0 to 1.11 and see how the Django test framework evolved over time. It all started about 10, 11 years ago, sometime before getting Django out of beta. This ticket gets created. Add unit test framework for end-user Django applications. And it lists all sorts of benefits that you can have while having an integrated framework to test your apps. But there's this killer argument. As an added incentive, this is a feature that is present in Rails. And that's how it started. It started with a management command, test. It accepts pseudopaths at the time that point to test. So you do app.testClass.testMethod. We get a TestRunner. A TestRunner is also a config variable that points to a function that runs your tests. That means that from the very beginning, anyone can write their own TestRunner and test discoverer. The TestRunner sets up the test environment, and it looks up for tests in files test.py and models.py. At the very end, the TestRunner tear downs the test environment and returns the results. At this point, you might be squinting and thinking, models.py? Is she serious? Well, 10 years ago, apparently, doc tests were very popular, and they were used to test ORM a lot. So models.py were the place where model and application level tests were meant to be, and everything else was left to test.py. Client makes its appearance as a basic stateful browser mimicking stub that constructs requests, passes them to the views, and returns a response, bypassing all networking altogether and interacting directly with the WSGI interface. At its core, client, it is the same client that we have today, it's just a more limited one. If you're writing your tests using Python unit test library, then you've probably heard of TestCase. Well, Django also has its own version of the TestCase, which is an extension of the unit test case, because it can also do extra things like load fixtures and clean the stubby mailbox and initialize the client and clean the data after each test. And it provides a couple of assert helper methods, for example, like assert redirect and template use, the ones that we actually still have today. Version 1.1 comes shortly after with a revolutionary set of HTTP methods. So RESTful APIs are not yet the next big thing, but Django's looking into the future and adds to the client put, head, delete, and options. Along with the test case, we also get a transaction test case. This is where we need to make a clear distinction what is the difference between a test case and a transaction test case. So a test case acts like a burger because it wraps each test into an atomic block. It enters the transaction, it runs the test does massive things to the database, and finally the test case rollbacks this transaction and leaves a clean slate for the next test. Because of that, a test case will always prevent any commits or rollbacks to the database, because it wants to ensure that at the very end, when it rollbacks the transaction, the test restores the database to its initial state. And this is a big performance booster to the test case and for us to writing our tests. If you want to use transactions, this is where you need to use transaction test case. It will clean up after each test by flushing the database at the start of each test. And by the way, the test case from the previous version 1.0 was doing exactly that. 1.2, Django defines a new interface for test runners. So we're switching from a function to a class. The class should have a method called runTest that will act as an entry point. By default, Django provides Django test suite runner. So this is not really related to the evolution of the Django test framework, but it's a silly bug that I really like, so I decided to put it in. So the test runner returns the number of errors plus failures all summed together. And what Django does, it spits out this number of failed tests as a sysexit. So if no tests have failed, then it will naturally exit with a 0, which is a success. If you have one test failure, then this is going to be 1, which is a failure. That looks correct. If you have 42 failed tests, that'll be fine as well. If you have 256, it suddenly becomes a success. Whoops. This is because sysexit number is an 8-bit number, so it overflows into a 0 when you have 256. And talking from experience, it's not very hard to get 256 failed tests. So we fixed it. We just say sysexit 1. So now we'll always either get a 0 for success or a 1 for a failure. 256 now is a failure, as it should be. Let's take a look at the definition of the test runner, because something changed from the previous version. There's a new argument, failFast. It allows you to terminate the test run on the first failure. And I find it very handy. The implementation has been removed ever since from the Django test framework because it's now available within the Python unit test lib. But good to know it exists. Django has support for multiple databases with a replication strategy. So you can have a primary database and multiple replicas can be created. This is how it looks like in DB settings. There's a default database and there's a replica. If the test mirror setting from the replica dictionary is missing, then there won't be any replication happening during your tests. Just the default database is created and tested against. If you want to test replication, then you need to set up a test mirror. And if you want to use it today, settings have changed, so should look like this. So let's go back to our databases. when the test environment is configured, a test version of the replica is not created. Instead, the connection to replica will be redirected to point to default. So as a result, the rights to the default will appear on the replica, but not because there's some sort of data replication happening between the two, but because it's actually the same database. 1.3, we can now do a set query set equal and a set number of queries, which is handy for the test case. We also see a split of the two roles that the client embodied. So the role of manufacturing requests is turned over to the request factory, and obtaining the response was left to the client. The request factory becomes part of the public documented API. So how do you manufacture requests with the request factory? Very simple. You just create a WSGI request object with a set of WSGI and request-specific attributes like the protocol, the request method, payload, cookies, URL scheme. That's pretty much it. Doesn't do anything else. Very simple, very factor-ish. So dog tests. In the beginning, it seemed like such a great idea. You get both tests and you get both documentation. In the long run, it became a nuisance to debug. It also became apparent that dog tests aren't really good at providing neither high-quality documentation nor comprehensive tests. That's why dog tests will be discouraged to be used in the future. And Django is a good example of a big project that came through a love stage with the dog tests and just proved that this relationship can't work. 1.4. In version 1.4, the family of the test case classes receives an extension pack. So we get the simple test case and the live server test case. Simple test case is very light because it doesn't hit the database. Live server test case runs an HTTP server so that you can use a testing framework like Selenium for your end-to-end tests. And it is based on the transaction test case. Version 1.5 is the time when Python 3 support landed in Django. Remember we talked about the transaction test case, and we said that it's flushing the database before each test. Well, at the time, other test runners become popular, for example, Nose, and developers figured out that there's a bit of a mess left by the transaction test case. So it has been updated so that now we flush the database not before each test, but after. Let me show you. So if you flush the database before the test, you get the following sequence of actions. You flush, you run the transaction test case, and then you can run your test cases. What happens is that right after running the transaction test case, you get some dirty state right in there. So your test cases actually start with a not clean database. That's why Django default TestRunner is always rearranging tests so that the test cases run first and then the transaction test cases come. And even though the transaction test case leaves some dirty state in there, it actually doesn't matter because we're going to destroy the database. But we can solve this problem in a different way. We can just flush after, and then all of our problems are solved, and it doesn't really matter in what order we're running our tests. 1.6. So there's one more HTTP method added to the client. This is patch. And if you thought this list is complete, it is not. In version 1.6, we see various improvements. We get a new test runner that is able to locate tests not only in test.py and models.py, but anywhere from the installed apps as long as it matches specific file patterns. The new test discovery also means that we have no more tests in models.py. Hooray! Pseudopaths are also removed. Now we can use real file system or dotted directory paths. This also allows running tests that are not inside a Django app listed in installed apps. And finally, dog tests won't be discovered anymore, and we say farewell to them. 1.7. So 3 versions before 1.7, Django introduced unit test 2. Unit test 2 is a backport of the unit test features that work with older versions of Python. And because Django at the time was supporting Python 2.4, it was vendoring unit test 2. In 1.7, Django drops support for older versions of Python, and so it removes the unit test 2, and we can just use the regular unit test. At first, when the live server test case was introduced, it was serving all the static files as if you were running your server with debug equals true. From this point on, live server test case will serve only files from the static root, trying to simulate the real production environment as close as possible. If you want to serve all of the static files, then you can use the static live server test case. In 1.8, we get the last known HTTP method to the test client. Can you tell me which one is that? Which one are we missing? HTTP spec, someone? Okay, this is trace. This is the last one. And once this one was defined, the client is complete. TestCase and its burger strategy was a performance booster. And around version 1.8, a few other intricate changes were introduced that made the test case even better. Before that, think version 1.7, what test case did is wrap each test into a transaction. But it did it in the following way. You would enter the atomic block, and you would load the fixtures, you would run the test, you would exit the atomic, in other words, roll back, and then you would close all of your database connections. And you would repeat that for every single test that you have. With the arrival of Django 1.8, we can do something better. So we actually wrap all of our tests from a test case inside of a different atomic block that is going to happen only once. And what we're doing, we are loading the fixtures and we are closing the connections a single time rather than doing it for every other test. So now every test within also runs within its own transaction block. But we get also the benefit of closing the connections and loading our fixtures a single time rather than doing it every time. 1.9. Whoever works or worked on a large project knows the pain of waiting for tests to finish. From my experience, that would take, the pain starts with about 20 minutes, sometimes it's 40, depends how large it is. And most of us know that the quick, easy win for that is to parallelize our tests. And also, that's the time when you find out how many non-pure tests you have. Django 1.9 comes with a built-in support for parallelizing tests using Python multiprocessing module. In fact, Django's test suite is also parallelized. How does it work? The TestRunner spawns a number of workers. So if you don't specify how many, it will pick up the max number of cores that you have. For each process, we'll get its own database. So each worker gets its own database. Therefore, if you have 4 workers, you're going to get 4 databases. Test Discovery builds a test suite, which is partitioned into chunks of test case subclasses. Workers pick up those subsuits of tests and run them. Once they're finished, they pick up the next one, and they're finished, and they pick up the next one until they're done, and they return the result. If you're stuck with a version of Django prior to 1.9, then you can use No's multiprocess plugin. It's also using Python multiprocessing module, but the main difference between the Django ones and the No's multiprocess is that you get only one database, so you get a shared state, and because of that, you sometimes can get bizarre failures and errors. 1.10. My favorite feature that was introduced in 1.10 is tags. You can tag your tests, creating buckets of certain types of tests that you'd like to run together or you would like to exclude from your test run. Similar feature is implemented by other test runners like Nose and PyTest. If you're not on Django 1.10, you always have the option to use Nose Atrib plugin or the PyTest custom markers. And finally, 1.11, we get all sorts of speed-ups and improvements. In fact, with every version, we continuously try to get better in different areas of the testing framework. But there's one feature that caught my eye, which I think is nice to know about. So starting with Python 3.4, unit test module adds a context manager called Subtest. It says, a subtest executes the enclosed block as a subtest. In this example, what happens is that the test won't exit on its first failure when I equals 1, because 1 is an odd number. It will actually run through all of the options, and it will return all of the results for all of the values of the I. So now with Django 1.11, you can do that. You can write your subtests when running tests in parallel, and Django will report all of the results correctly. If you're with PyTest, this probably looks familiar to you, because PyTest has parameterize. We went through the history of the Django test framework, and we've touched on different topics here and there. But let's see the flow of running a test suite as a whole, or what happens when you run manage.py test. So let's split up the test bed into multiple pieces and analyze each one of them and see what happens under the hood. We invoke the management command test, and if we zoom in, came back. And if we zoom in, there's pretty much a straightforward invocation. So we're getting the TestRunner, and we're creating an instance of it, passing a bunch of options, and we run the tests. Let's zoom in inside run tests. So the first line in run test is setting up the test environment. That will do a bunch of things. So the main three key points of this method is setting up the lockmem email backend, so that all of the email that we're sending during tests is stored into a stub list that we can inspect, and we can access it easily. This is a very reduced email backend in its functionality. We also get the Django test renderer is replaced by an instrumented test renderer. It sends signals to let others know about various events that happened during rendering. And finally, we deactivate translation so that during tests, your project will, the test will respect your project set language. The next step after setting up the test environment is to build the suite of tests. The heavy load of building the suite is done by the Python unit test library. But Django extends it because it allows you to specify tags, a number of cores, and debug mode, and all the different things. So it builds up a suite of tests. This is an aggregation of instances of TestCase classes all collected in a single place. And there's nothing more than that. The next step, we set up the databases, we run the checks, then we run the test, which is, by the way, completely delegated to the unit test text test runner. And for the cleanup, we tear down the databases. Afterwards, we need to tear down the test environment. This is pretty much the reversed order of what we did in the setup test environment. So we need to bring back the original email backend, the original test renderer, and finally we delete the state and the mailbox. Last step, we return the results of the test suite by combining the number of total failures and errors. And these lines should probably look familiar to you at this point. A quick recap on the different test classes and how they relate to each other. So this is the hierarchy, and the simple test case is at the very top, subclassed by the transaction test case, which is subclassed by the test case and the live server test case, finally specialized version of the live server test case, which is the static live server test case. I've been saying test so many times. Simple test case is very, very fast because it doesn't interact with the database. You can't query, you can't save, you can't do any of those things. It has access to the test client though, so think of it as a slightly more advanced version of the usual Python unit test case. transaction test case is not fast at all, but it allows database queries and transactions. Test case is faster than the transaction test case, but not as fast as a simple test case. It will allow you to do database queries, but will restrict transactions. Live server test case will act as a transaction test case, and it will launch a live HTTP server in a separate thread from the thread that's running the tests. And finally, the static live service is the specialization that, in addition to everything else, will serve all static files. Client is a very handy utility when you're testing your Django apps. And the three core actors involved in browser mimicking are the request factory, client handler, and the client. We've talked about the request factory being the most straightforward actor. It constructs requests and it encodes data. Client, on the other hand, performs more actions. First off, the client is stateful, so it retains cookies and hands sessions for the duration of the test client. It also does a few other things to the response. So we talked about the instrumented test renderer. Well, the client is listening to those events. Events like template rendered and a request exception, and that's why it is able to list all of the templates and template context that was used to render your response. It also sets a couple of other things on the response, for example, the original request, the client object, a JSON, a resolver match. It can also handle redirects and build a redirect chain that you can inspect. Main goal of the client handler is to return a Django HTTP response with the WSGI request attached to it. It will load all the middleware that you've set in your settings. It will disable the CSRF checks, which can be enabled back if you want to. And it tries to emulate as close as possible server and browser behavior. We've talked about all the different tools that Django provides for testing. But how do we achieve quality in our tests? How do we make sure that the tests we write are reliable, future-proof, and fast enough? Reasoning about quality is not easy. Besides our intuitive human understanding of what quality is, there are some tools that can help us. And let's start with something simple. Introduce Factory Boy to your tests. Lots of people like it because it has these shortcut methods for creating models. It generates random yet realistic data because it's based on a different library called Faker, and Faker has providers that, based on certain rules, create this random yet realistic data. The important part, though, is that every time you run your tests, you'll get different values compared to what you get with fixtures. And there is a slim chance that Factory Boy might catch a bug for you. If you're interested in this kind of stuff, I'd suggest looking at the Python's hypothesis library. It's doing property-based testing, and it takes the idea of random input to a whole new level. So the idea of the property-based testing came from a Haskell library called QuickCheck, and Hypothesis is the Python implementation. You can use, so the way you do it, you use a given decorator, which can inject randomly generated data to your tests. You specify what kind of strategies do you want. So in this case, we're using a strategy text, which is very similar to the Factory Boy's providers. And what it does, once we decorate a function with the given function, this test will run multiple times, usually about 200, and it will test your function with all sorts of different edge cases that usually, that often easily slip away from developers' attention. Since Django is an established way of doing web development in the Python world, Hypothesis comes with an extra module with support for Django. Similar to Factory Boy, we can create models populated with random data. To be noted, with the hypothesis, we always save the created model examples. So this is a real-world example of how hypotheses can be used for testing Django apps. If you look at the very top, at the 4 imports that we have, there's one import that is the most important, and this is the test case. We're using the hypothesis test case to be able to wrap each hypothesis test into its own transaction rather than running all 200 of them in one single transaction, because then we'll get a mess. So let's remove the imports and focus on the test. This is a slightly stripped down example that I borrowed from a presentation made at a Django local user group in London, made by the author of Hypothesis, Dave. So we are testing, what we're testing here, we're testing that if the project model instance can respect the limit of users a single project can have. You can specify a collaboration limit. On this project, I just want to have 3 people and no more. So what we're doing, we are injecting one project model instance and a list of random amount of user models from 0 to 20. Then we check if the project is at its collaborate limit and we try to add another user, we expect an exception to be raised because we don't want to accept more users than we have at our collaboration limit. Otherwise, adding a new user should work just fine. And when you run the test, if hypothesis encounters that the test didn't succeed with a set of randomly generated data, it will tell you falsifying example. So in this case, we have a project with a limit, with a collaboration limit of 1, and we've been able to add 2 users where the second one didn't trigger an exception, which means there's something wrong. You have a bug. But here's the catch with all of that. Tests are best kept when they're simple and stupid. And one should not have bugs in their tests. With hypotheses, tests can become more complex, and you might even reach a point where you will need tests for your tests, which is ridiculous. So when using, when used properly and timely, property-based testing can be a very valuable tool. So keep in mind that test code coverage is probably the most known and widely used metric. So about a week ago, I checked Django's test code coverage. I ran it against SQLite and I got 75%. But here's the thing, test coverage is generally a deceptive metric. If you have low code coverage, then yes, you definitely need more tests. You're probably not testing your code properly. But if you have high code coverage, well, it might be that your tests are very good, but maybe you just kind of wrote them in a way that you hit all of the lines of your code, but you didn't roughly tested it. So unfortunately, in my opinion, high code coverage doesn't necessarily imply high quality of tests. We can do better. We can do better with mutation testing. Mutation testing is a concept that was introduced in the 70s, and it involves changing the code of a program in some small ways, like little tweaks, and observing what happens when we run the test on this modified version of the code. And this is a very powerful idea. I thought it's so simple and yet so brilliant. In Python, mutation testing is implemented by a package called ModPy, and ModPy operates on the Python AST to implement mutations. So how does it work? You invoke mutation ModPy from the command line, and you need to specify your target and your unit test. The unit test obviously needs to test your target code. So if your target source code has an if statement, and the if statement has a logical operand AND, so you're saying if foo and bar, then do this. ModPy takes this logical operand AND and inverts it into an OR. So our target code becomes a slightly modified version of the original, and we call it a mutant. Now what we do, we run the test on the mutant. If the test failed on the mutant, this is good. We say that the mutant was killed by our test, which adds points to our final mutation score. But if the mutant survived, then our test isn't good enough. It means that it doesn't really matter if we're using and or the test pass anyway. We're probably not testing what we should be testing. And ModPy can do a lot more. There's a fairly long list of mutants. It can replace arithmetic operands, break continuous statements, conditional operands, constants, logical operators, and it can even delete whole conditional branches and decorators and do a lot more. This is what a stripped down example of a test run looks like. You get a mutation score, which is a percentage, in this case 32.1, and it also tells you the total amount of mutants that it generated, the number of mutants that were killed, survived, incompetent, timed out. And I took this tool and I started playing with the Django test and see what results I can get. So one pleasant trend is the correlation of the high code coverage with the high mutation score. For example, Django duration utils has a mutation score of 89 and its mutation score is 100%. This looks really nice. This doesn't always hold true. For example, Django encoding utils mutation score is 64%, while the test code coverage is 100%. So you can see that mutation score can actually give you better insights into how good your tests are. Django tutorial is excellent. Beginners don't need to search the internet for any video tutorials or courses, because if you go to the Django official webpage, you get the Django official tutorial. And a whole section of it is dedicated to testing, because testing in the Django world is an integral part of developing an app. In my second year at university, I discovered Django. It's also the first time that I wrote a test. It was a very silly one. I was just making a request to a URL and expecting a 200 response, But you know why I wrote this test? Is because when I followed the tutorial and I created my Django app, I also got this file, test.py. And that caught my attention. The tutorial explained exactly what I need to do to get started with testing my code. So a testing framework is a powerful tool to motivate people to write tests, and especially beginners. Django testing tutorial contains a section named "When testing, more is better." It says that yes, soon enough, you're going to feel like your project is spinning out of control because it grew so big and you have so many tests, but just let it spin out of control. It's fine, let them grow. When testing, more is better. There's a trap in there. With the number of tests growing, your total test runtime becomes slower. And Django gives you all of the tools and encourages you to write very high-level, sort of functional style tests. So the speed of your test can suffer. And this has other implications. With slow tests, you get a slow feedback loop. With a slow feedback loop, you get a slow development cycle. Sometimes if tests are so slow, people just stop running them. And that's why here are 7 tips on how to make your test not be slower than they actually need to be. And number 4 will shock you. Number 1, use a fast and less secure password hasher during your test, like MD5. This is what Django does for its own tests. Abuse simple test case when possible. If you don't need the database, if you're just writing simple tests, use simple test case. It's brilliant. Use setup test data if you don't plan to mutate any of the objects that you create in it, because it's going to be called just once. And here's the shocking bullet point, number 4. Use mocks everywhere. And I'm joking, I'm not serious. Just trying to emphasize that, yes, this is a joke. There's nothing inherently bad with mocks in themselves. Mocks are a really good tool that you need to know how to use. But if you're using mocks with the intention of speed-ups, then there's probably something wrong in your app design and not in your tests. Mocks are really good for isolation, so use them for isolation. Be very careful what gets created in the setup method. Don't save model objects if it's not necessary, and try to isolate your unit test from the rest of the your tests. And I would like to talk a bit more about the last 3 points. So last year I learned that this is called the tight loop. So a tight loop like this, where we create some model instances, are red flags that need to be identified, removed, or reduced. Instead of doing create, how we did in the previous example, what we can do, we can create an in-memory model, just like this. Similarly, an in-memory model can be created using a factory build method, or you can create a stub object, which is just a couple of attributes using the stub method. The last two are taken from the factory boy. The caveat here is that you can't always do that. For example, when you have a many-to-many relationship, you just have to save the model. And finally, isolate unit tests from the rest of your tests. Your test suite may look like this. It's a mix of Unity, unit-ish like tests, functional integration tests, but it would have been a lot more useful and would allow creating a faster feedback loop if we separate unit tests from the rest. Because you can run unit tests all the time. You can even run them in a watch mode, and they're really fast, and they're going to give you the results instantly. And then you can run all the rest of the tests less often. One way to do it is to use simple TestCase classes for unit tests and tag them with a special label if you're in Django 1.10. If you're stuck with an older version, you can separate them in a different folder so that you can run them in total isolation from the rest of the tests. Even better, you can make them simple unit tests or PyTest, which have no idea of what Django is, and write more of them. But don't neglect functional and integration tests, because obviously they are the one that validate the contracts between your units. So you definitely should have both. Say your friend runs a little bakery business and they sell freshly baked bread and other similar nibbles. They hire you to help them build an internal app for them. What the app needs to do is to help them figure out what should be the correct VAT value for their products, and this will save some time for their account because taxes. So we start with a basic naive schema where we get the product model and the product questionnaire model with a one-to-one relationship between them. The product questionnaire is the key to our VAT decision making. It's a little add-on where we define basic yes or no questions and we build a decision tree to eventually land on a defined answer. Is this product 0 rated VAT or is it a standard rated VAT? We'll need a view and we'll need a model form. The view will display the questionnaire and answers will be saved on the product model on the product questionnaire model for possible future recalculations. In the same view, we'll converge to a final decision and save it to the product. With a known VAT value, it's going to be really easy to compute the final price of the product. So I'll be showing example code for different approaches on how to solve this problem, where at the very top we're going to have the production code and at the bottom is going to be the test code. Solution number 1. In a view, once we know that the form is valid, we check if the product is a biscuit and is it coated in chocolate. So in that case, we're going to set the VAT to 20%. This is a class-based view because of its brevity. If you have an allergy towards class-based views, you can just translate it in your mind into a function-based view. As for the test, what we're doing, we're creating a product object. We are making a request by passing some data, and then we are refreshing the product from the database, and we're checking if the VAT equals to 20. In reality, we understand that the if-else is going to be much bigger. We can split it into multiple methods, but the essential part is that the entry point of this calculation is going to be in the view. And for each branch, we're going to have one test, and each test will do the same thing. It will create a product object, and it will make the request, and it will check this VAT value. And they'll be just repeating ourselves, and we're going to do it for biscuits and bread and flapjacks and other items. So to test each one of those items and to check their VAT value, we will also be testing the router. We'll be interacting with the database to eventually send an input to receive an output. And if you're thinking that you can remove the database interactions with the mocks, I think mocks are not a solution in this case, because we can do better. Solution number 2. The conditional check gets moved to a more appropriate place, the form. So in the test, we're again creating a product model. We are instantiating the form. We're passing in some data, checking if the form is valid. We're going to save the form, refresh the product from the database, and check if the VAT equals 20. To test it, we again need to create a product object, but we are no longer testing the routing, which is an improvement over the solution number 1. Via the form, we send an input, the answers to the questions, to receive an output. Further, the last solution moves the entire decision-making to an old, boring Python class, or a function if you want to. It has a method called calculateVAT that does exactly what it says. And in the test, we're instantiating the VAT calculator, calling the method with a bunch of arguments, and we're expecting the result to be 20. Somehow, we forget that Django is a web framework, not a programming language. Different constructs can live outside of core Django components. The VAT calculator has no idea what Django is, and it doesn't need to. When testing, we're not testing the router, we're not testing the ORM. All we do was sending an input to receive an output. And what we did is called decoupling. Decoupling has various benefits. Reusability. As a developer, I can pull out the VAT calculator and build a separate app that calculates VAT and helps others maybe figure out their VAT values. Extensibility. If my friend decides to expand their little business to a new country, and this place has different VAT values, it's going to be much easier to update them in one place in the VAT calculator rather than going for all of the views and forms and trying to update it there. And finally, testability. You saw how easy it was to test the VAT calculator. This approach of isolating business logic allows creating more and faster unit tests and keep the functional and integration tests at a manageable rate. Tests have more in them than we think. A test has the capability to drive a better app design. In terms of Django, it's about moving complex logic away from any Django-related components. If it's a complex behavior that isn't directly tied to the database, templates, forms, or views, then build objects that perform those complex actions and unit test them. Thank you very much for your undivided attention, and happy testing, everyone.